Okay guys, here's the information about the rice tables like I was telling you. No, it's not a little Japanese man eating sushi, okay? But it's an interesting way to think about it. Basically what this is a technique for solving equilibrium problems when they are asking you for the concentration of the products when, or even the reactants, when it reaches equilibrium. So you should have one half of the reaction or portion of the reaction, and you want to figure out what the other portion is. So let's say they give you the initial concentration of the reactants, or they give you the final concentration of the products and ask you for either of the other two. Okay, so basically this is an algebraic way to solve this. Now the reason why it is called a table is it's a table method, okay? I call them rice methods, or you'll often hear them called the ice box because it makes the shape of a box. Basically what you're going to do is it's an acronym, so R-I-C-E, okay? A lot of people leave out the R because they don't need it. But basically what the R is you are going to write your equation, okay? And you're going to want to leave yourself enough space, and I'm going to work a few of these in just a second. So you're going to write your equation down, and when I mean your equation, this is your chemical equation. A plus B yields C plus D, okay, whatever that is. I stands for initial concentrations. So what is going on at those initial concentrations? What are you dealing with? Okay? The problem should give it to you, or in this case, sometimes they ask you to solve for it. Okay? C stands for the change in concentration, and I hope you can read my handwriting. And E stands for the equilibrium expression, okay, or the equilibrium state, okay? And this basically is where we are going to add lines I and C together, okay? So that is the general gist of a rice table, like what it is. Now let me go on and go ahead and work one for you. So this is number 8 from the problem that's from the packet that I gave you today to work on in class. Basically, we are dealing with the reaction of hydrogen iodide breaking into hydrogen gas and iodine gas. Okay, so let's break this down first of all. Before I even start my problem, I'm dealing with all gases. Okay, so my equilibrium expression should have every piece of the pie in there. I am dealing with a certain temperature that will come into play later. It says 1 temperature, 1 atmosphere. I have 8 molar initially, so that is my initial concentration of 8 molar, and I have my Kc as 28.8. This particular problem is asking me for the Kp. Well, I can't solve the Kp until I solve all of the concentration pieces, right? I can't solve the entire equilibrium expression until I have all the pieces. So what I'm going to use, this is a good example of how to use a rice table. So again, R-I-C-E, okay? I'm going to write my equation, and that happens to be 2HI yields H squared plus I squared. And I am giving myself some space basically because I'm going to have to write underneath this like a table. My initial concentrations, they give me HI, and that's 8, okay, 8 molar. But what is going on with H and I? So hydrogen and iodine. What is their equilibrium expression? If this reaction is just now starting, their initial concentration should be 0, okay? Like, there's nothing there. The reaction just got started. We're timing it the moment we put the HI in the container, okay? Now we have to figure out what's going on. This is where the change line comes into play. And here we got to think a little algebraic, in a little bit of an algebra mind. What is going on here? So we have we're going to lose HI. HI should be going down. So the hydrogen iodine is going down. We're not sure how much, but we do know we're going to say it goes down by 2x. Okay? We're not sure what x is, but we know it's going to go twice as much. I got the 2 from the stoichiometry in the reaction above. Okay. Well, if it's going down by 2x, both hydrogen should be going up by x, and iodine should be going up by x. Okay? All we do on the equilibrium expression line is we add up I and C together. So here I have, it's going to be 8 minus 2x plus x plus x. Now what I want to do is plug this in to my equilibrium expression. So my equilibrium expression is K equals, it's products over reactants. Okay. So in this case, I have X for the hydrogen and X for the iodine over my 8 minus 2x squared, because remember that I have 2. There's a 2 exponent in front of there. So if this is my equilibrium expression, now it's going to take a little algebra. Well, as you can see right up here, okay, that's 2x. Or excuse me, not 2x, but that's x squared. So if that's x squared, and the bottom is 8 minus 2x squared, then I should be able to go ahead and take the square root. So this is where your algebra skills are going to come in, and you guys are algebra ninjas. You're faster than I am. You're in that math mode, so please don't stress about these. Do your algebra. You know what to do. So to solve this problem, I need to plug in my Kc. I'm sorry, I forgot to plug in my Kc. That's an important value that we need to know. So if I'm going to reduce this equation down, I have 28.8 equals x squared divided by 8 minus 2x squared. Okay, so here's the point where I'm going to take the square root of both sides. If I take the square root of both sides, I'm going to end up with 8 over, x minus 8 over 2x equals, square root of 28.8 is 5.37. Okay. So now it becomes an algebra problem. I'm not going to belabor how to do the algebra. I'm going to let you handle that. If for any reason you have a question about your algebra or get stuck, please come see me or go see your math teacher after school. Okay, so if I solve for x, I'm going to end up solving that x equals 3.66 molar. So what does that x mean? Okay, that x means that that is the concentration of my hydrogen and iodine. And now I need to find the concentration at equilibrium. Okay, so both hydrogen and iodine, now these guys here, okay, now have a concentration of 3.6 molar, 66 molar. What happened to my concentration? What is my equilibrium concentration of hydrogen iodine? Okay, well, hydrogen iodine started out at 8, but I'm going to have, so the new concentration of hydrogen iodine is 8.00 minus 2 times x, which is 3.66 molar. Okay, so my hydrogen iodine concentration is now 0.681 molar. Okay, so it has now been reduced. And I am talking kind of quickly. I'm trying to split up this video into multiple pieces. So that is basically how to use a rice table to solve, but this question isn't done. It's asking for what is the value of Kp. Well, we did one example today in class, so I'm hoping that you can now use your Kc value, you have the Kc value at 28.8, and you need to find the Kp value. So use the equation that we used at the end of class today to find that. But you needed this information to solve for that first, okay? So this is the basics of a rice table. I want you to focus on how to use the rice table and the other parts we've talked about in class, okay? So I'm going to do one more for you, and we'll see how that goes.